Now we have already discussed this formula that work is what? Dot product of force and displacement, right? So if force and displacement, both the vectors are given you in this format, for example, vector F is given as Fxi, that means the component of force along x-axis. Again, this is a vector, I don't need to go back into details, we just discuss in dot products. So Fxi plus Fyj plus Fz and k, right? And displacement is given by, suppose the object has done a displacement x along x-axis, y along y-axis, and z along or z along z-axis, right? That is k. So the dot product would be like what? We have discussed this thing. Instead of writing F dot S, you can simply write work done is equal to, the dot product of these two would be the x component into x component, that is I component into I component, which is Fx into x plus Fy into y plus Fz into z, right? This will be the straightforward answer. Now what is the SI unit of work done? For example, we have, do we know the SI unit of force, which is newtons, right? What is a newton? Force is defined as product of mass and acceleration. I'm not going to technical definitions. Force is a push or pull which changes or tends to change. No, not that definition. In simple format, in terms of, because right now we are doing the SI unit. So SI unit of work would be, it is called joules, and what I unfinished just now was for work is force into distance, right? Generally, because if I even write the complete formula cos of theta, cos, the trigonometric ratios are actually dimensionless. So I still have to go back to F and S. The SI unit of force is newtons, and I was telling you what is a newton. In general formula of definition, force is product of mass and acceleration. 1 newton is 1 kg into acceleration is what? 1 meter per second square. So I'll write it here, 1 kg into, this is acceleration, meter per second square. Okay, this complete is a newton, and this displacement is what? Meter. So 1 joule is 1 newton into 1 meter. So if you have to define 1 joule from this statement, how can we define it? 1 joule is that amount of work done when 1 newton of force applied on a body makes the body move by 1 meter, or when 1 newton of force displaces a body by 1 meter, then the work is said to be 1 joule. You can define it any way you like it, alright. What is the Cgs unit of force? Here what I didn't write was, meter is the meter is this thing, meter is, I want to go to the dimension formula of work done. I have already told you, before dimension formula, let's do the Cgs unit first and then we'll go to the dimension formula. What is the Cgs unit? Cgs unit means centimeter gram second unit, which is SI unit of force and the Cgs unit of force and Cgs unit of displacement. So Cgs unit is called ergs. 1 erg is 1 dyne into 1 centimeter. What is 1 dyne? 1 dyne is 10 raised to power 5. No, 1 dyne is 1 dyne. If I have to write ergs in case of joule, for example, I am writing 1 joule is 1 newton into 1 centimeter, and I have to convert joule, I have to relate joule and ergs. What can I do? I can change the SI units into Cgs units. This was 1 meter. SI units into Cgs units. So 1 newton is how many dynes? 10 raised to power 5 dynes, right? And 1 meter is how many centimeter? 10 raised to power 2, that is 100 centimeters. So I get 10 raised to power 5 into 10 raised to power 2 is 10 raised to power 7. You know the powers gets added up. So 10 raised to power 7 dyne centimeter. So 1 joule is actually 10 raised to power 7 ergs. Alright. Lastly, the dimension formula. How do we calculate the dimension formula? How do we, actually I have told you n number of times that please stop learning or mugging of the dimension formula. You can actually derive it whenever you want. See, I have to find the dimensional formula of work, but I'll give you the dimensional formula of both work as well as force right now, because dimensional formula are a very integral part of this syllabus. It will be required everywhere throughout your +1 and +2. First, let's start with force. I want to write the dimensional formula of force. This is how we denote the dimensional formula when we put some physical quantity into the square brackets, right? So, what is the formula of force? Mass into acceleration. That means dimensional formula of mass into dimensional formula of acceleration. So, mass is represented as m. Acceleration, what is the unit of SI unit of acceleration? It is meter per second square. Meter is what? Length per second square upon t square. So this becomes t minus 2. So you have mlt minus 2, which is the dimension formula of force. So dimensional formula of work would be dimensional formula of force into dimensional formula of displacement. Force is mlt minus 2 into displacement is whatever the units would be, it will be L in dimensional form. So this becomes ml square t minus 2. So this is the dimensional formula of work.